Hey everyone, and welcome back to The Explainer. Today we're diving into a really fantastic lecture from Skip UNI, breaking down one of the absolute most fundamental and honestly coolest concepts in object-oriented programming: classes and objects. Seriously, if you've ever wanted to know how modern software actually gets built from the ground up, you are in the exact right place. So let's just jump right in.
Here's our quick roadmap for today. We're going to cover 1. The OOP interview requirement. 2. The blueprint analogy. 3. What exactly goes inside a class. 4. Creating real-world objects. And finally, number 5, we'll code an actual C++ example together.
All right, Section 1, the OOP interview requirement.
Okay, so here is the absolute most crucial thing you need to know. If you're walking into a tech interview today, whether that's at a massive product-based tech giant or a huge service-based company, your programming skills have to be on point. And right at the very top of their checklist, yep, object-oriented programming, or OOPs. Now, your interviewer might ask you to write code in Java, or maybe they want C++ or Python. The exact syntax for those languages will be totally different, for sure. But the underlying core concepts of OOPs, things like classes, objects, and the stuff we'll cover later, they literally remain exactly the same across the board. Mastering these foundational ideas right now is totally your key to passing those high-stakes interviews.
Moving on to Section 2, the blueprint analogy.
So, formally speaking, a class is defined as a user-defined data type that acts as a blueprint for creating objects. Now I know, that sounds super academic and honestly a bit like a mouthful of jargon, but don't worry, let's break it down. To really visualize this, imagine a massive empty plot of land. You're planning to build a huge colony with dozens of gorgeous villas. But before you lay a single brick, what's the very first thing the architect has to do?
Right.
They have to draw a map, a blueprint.
And it's actually amazing how perfectly this architectural analogy maps to programming. A physical house blueprint specifies exactly where the bedrooms will go, where the kitchen is, the washrooms, and all of their exact dimensions. It's the master plan, right? Well, a programming class does the exact same thing, just for digital data. It maps out the precise structure of the data and the functions we're going to use. Basically, the class is your software's master plan.
Which brings us to Section 3. Inside a class.
So, inside every single class, we have what we call members, and they generally fall into two main categories. First up, we've got attributes, which you might already know as variables. Think of these as our actual data storage, like integers or strings. If we go back to our house analogy for a second, these attributes are the individual rooms in our house. Second, we have methods. These are basically the functions that dictate exactly how we use, manipulate, or read that stored data. So if the attributes are the physical rooms, the methods are basically the rules for how you interact with those rooms.
Let's make this totally concrete with a real-world example. Imagine we're building a software system for a university, and we need to design a student class. What exactly goes inside this blueprint? Well, our attributes, our data storage, would be things like the student's ID number, their name, and their father's name. Then our methods, the actions we can actually take, would be functions like, say, create new student profile or update student marks. This single blueprint perfectly defines what a student is within our entire system.
All right, let's look at Section 4, creating real-world objects. 500. Okay, this number perfectly represents the sheer efficiency of object-oriented programming. Think about it. Once you've drawn up that one single architectural blueprint for a villa, you don't just use it once and throw it away, right? No, you use that exact same map to build 100, 200, or even 500 identical physical houses on that plot of land. In programming, those houses you build from the blueprint, those are our objects.
So, simply put, objects are the real-world entities generated from your single-class blueprint. Jumping back to our university example real quick, it literally does not matter if a college has just 10 students enrolled or a massive 100,000 students enrolled. Every single one of those real individual students in the database is an object. And the coolest part? Every single one of them was generated using that one single student class blueprint we just talked about. You write the plan once, and you can create an unlimited number of entities from it.
And finally, Section 5, coding a C++ example. Let's step methodically right through the C++ syntax, because I promise it's actually really simple once you know the logic. Step 1, we just name our class, so we'll write class student. Step 2, we set an access specifier. Here we're using public, which just means our data can be freely accessed from the outside. Step 3, we define our attributes inside the class. We'll set up a string variable for name and an integer variable for age. And step 4, we define our method. Let's just create a super simple function called void display that we can use to print out the student's name and age. And bam, just like that, you've coded a complete class blueprint.
Okay, so how do we actually build the houses? Like, how do we create the objects from this code we just wrote? It is wonderfully straightforward. To create an object, you literally just write the class name followed by whatever you want to name your object. So typing student01 semicolon creates your very first student object. Student02 semicolon creates your second. Student03 creates your third. You could effortlessly create 10,000 objects using this exact same syntax. And whether you're coding in C++, Python, or Java, this is the universal flow of object-oriented programming.
We have covered some incredible ground today, but I want to leave you with a final thought directly from the source material. In our C++ code, we explicitly labeled our class data as public. But what happens if a stranger from outside the system tries to access or alter your carefully designed blueprint data? Like, do you really want just anyone wandering into your digital house? Next time on The Explainer, we'll dive right into the next Skip UNI lecture covering access specifiers and private variables. Until then, keep coding, keep learning, and I'll catch you in the next one.